Okay, so Google just released an update to Gemini DeepThink. Now it's powered by Gemini 3. And everybody's kind of losing their minds on benchmark numbers. 84% on RKGI2, gold medals on Math, Physics, Chemistry Olympiad, and legendary Grandmaster on Code Force. Now, these are impressive, but if that's all you take away from this release, you are missing the actual story. Here, Google actually did three things all at once, and most people are conflating all of them into one announcement. So there is a product update of DeepThink version 2 shipping to subscribers. Then there is a research agent called Aletheia that nobody is really talking about, but it's very critical. And there are 2 archive papers documenting 18 solved research problems. So the distance between what was shipped to the consumers and what is happening in the research lab is the real story here. So let me try to break it down. Now, first, let's get the benchmarks out of the way because that's what most people are talking about. For humanities last exam, we're seeing 48.4%. This is a benchmark specifically designed to test the absolute limits of frontier models when it comes to human knowledge. Then there is ArcAGI2. Now here, it's able to get 84.6%, which is 15 points ahead of Claude Opus 4.6 and over 30 points ahead of GPT-5.2, which is kind of crazy. Ooh, I don't think we were expecting this. And then there is Code Forces. So it gets an ELO score of 3455, which is pretty incredible because this puts Gemini 3 DeepThink at the 8th best competitive programmer position in the world right now, which is a very incredible feat to say the least. Now, there is a lot of discussion about the actual effectiveness of Gemini 3 as a programmer compared to some of the other models. We're going to talk about that later in the video. Now, let's specifically talk about this ArcAGI2 score because this is probably one of the most important results for DeepThink. So first, the cost story. DeepThinks cost about $13.62 per task. That's actually 82% cheaper than the earlier DeepThink versions. Now, this matters because a company called Poetic built an agentic harness on top of regular Gemini 3 Pro that hit 54% on RKGI2 at $31 per task, which was way less than $77 per task of earlier version of DeepThink. So these systems are becoming extremely smart at a reasonable efficiency now. So that tells you something about what DeepThink actually is. Now, one thing to consider, some of the benchmarks that Google reported for Gemini 3 DeepThink uses tools on compared to tools off with some of the other providers. But before that, let's talk about what DeepThink technically is. And this is important because a lot of people think it's a separate model. It's not. DeepThink is a reasoning mode within Gemini 3. It is the same base model, but it allocates additional compute at inference time. So instead of giving you the fastest possible answer, it thinks longer before responding. Now, to understand this, here is a very high level overview. Standard chain of thought is linear. So step 1, step 2, step 3, and the model is done. Now, in case of DeepThink, it does something different. So DeepThink does something significantly different. It explores multiple hypotheses in parallel, tests each one of them, refines the best, verifies it, and then gives you the answer. And more critically, it can backtrack. So let's say if you go down hypothesis 1 and hits a dead end, it can reverse course. Standard chain of thought cannot do that. More importantly, the number of reasoning rounds is also dynamic. So a simple question might get 2 to 3 rounds, and a complex physics problem might get 10 rounds and more. Now, here is the real number that matters the most. The January 2026 version of DeepThink reduced the compute required for Olympiad level performance by 100x compared to the July 2025 version. And this showed that the inference time scaling loss continues to run beyond Olympiad problems into PhD level exercises. You don't need bigger models. You need smarter allocation of compute at inference time. Let the model think longer. Let it explore more paths along the way and backtrack when it needs. And you get dramatically better results without touching the weights. Now, alongside the product update, DeepMind published a paper introducing Aletheia, which I think is the most interesting update, and nobody's talking about this. So this is a research agent built on top of DeepThink, and it tells you where exactly the technology is heading. The Aletheia agent works as a three-part loop: generator, verifier, and reviser. First, verifier takes a research task or problem and proposes a candidate solution. Then the verifier, which is a separate natural language mechanism, checks the solution for flaws. We're not talking about just looking at does this look right, but actually probing the logic for gaps and hallucination. And then the last step of this whole architecture is the reviser, which basically patches minor issues, or if the solution is critically flawed, it triggers a complete restart back to the generator. Now, there are two things that I've personally found very interesting. So first, Aletheia uses Google search and web browsing to navigate real mathematical literature. And this is huge because foundation models hallucinate citations constantly in specialized domains. In this case, Aletheia is grounding its citation to a specific reference. Now, the second one is that it can admit when it cannot solve a problem. And this is huge because LLMs by design are very confident and they will hallucinate results or it's going to make up stuff. But they specifically train this agent to admit when it cannot solve a problem. Now, the question is, what did Aletheia actually achieve? We're looking at 91.9% on advanced proof bench. The previous record was 65.7%. And this is not just incremental improvement. Now, here's the most interesting bit. On the 29 out of 30 problems where Aletheia actually returned a solution, its conditional accuracy was 98.3%. But here is the results that matters the most. Aletheia outperformed standard DeepThink at every single compute scale they tested. So we're talking about the agent wrapper with this generate, verify, revise loop is going to be more important than throwing just raw compute at the base model, which is significant. That means that the harness around the model itself is going to be more important than just trying to increase the test time compute. Now, we see this pattern everywhere. So Poetix beats raw DeepThink on RKGI2. That was the previous best. Cloud Code with tools performs better than the base Opus or Sonnet models. So I think the meta lesson of this year is going to be very clear. The agent layer is where the real capability gains come from, not just the base model itself. To this point, there's a very interesting blog post from Ken Bullock where he showed that just by changing the tool the models have access to, you can easily get 5 to 8% performance improvement on the model itself, which usually is not possible with even the update to a next generation model, which is kind of a very interesting point. I will probably cover that in another video. Now, with Aletheia and DeepThink Gemini 3, they also released two different interesting papers. The first one was towards autonomous mathematics research, and the second one is accelerating scientific research with Gemini, case studies and common techniques. In this, they collaborated with domain experts on 18 research problems. We're not talking about just benchmark problems because I think everybody talks about benchmarking, but these are real open research questions that humans has been stuck on. And they show that agentic systems based on Gemini 3 can actually help solve some of these research questions, which is fascinating because now we're going to be able to do research with the help of these agentic systems. So let me talk about three interesting ones. There are a total of 18. They are documented within this blog post and in the paper if you are interested. Now, the first one was that it was able to dissipate a decade-old conjecture. In the second example, it crossed mathematical boundaries by pulling tools from an entirely unrelated branch of mathematics to solve a problem that was unsolved. And in third case, it caught a critical error in cryptography. Well, none of them are my domain expertise, so I'm not going to even pretend that I know anything about them, but they are in the blog post, which I'll highly recommend to read if you're interested. Okay, so before somebody starts making a video claiming that AI has solved mathematics, I actually want to highlight something very important that unfortunately gets ignored in the headlines that we see. So in here, they say that the results of this paper should not be interpreted as suggesting that AI can consistently solve research level mathematic questions. And this is very important because previously some of the frontier labs have made claims about solving certain problem sets and they had to take them back. So here is what exactly Google DeepMind is saying. The first thing is that out of the 700 open problems that are on the Erdos problem set, they filtered it down to 200 AI generated responses, which were graded by humans. Now, out of those 200, 63 were technically correct. 4 were autonomously solved. We are looking at a success rate of about 6.5% on research grade problems, which might look small, but this is a significant success rate compared to some of the earlier models that we have seen. Now, DeepMind also created a taxonomy of how they're thinking about solving research problems with AI. So there are 4 different levels for a solution proposed by AI systems. So level 0 is reproducing known results. And this has happened with some of the OpenAI models. Level 1 is novel but incremental. Level 2 is what they're calling publishable quality. Level 3 is major advances. And level 4 is what they're calling landmark breakthrough. And they explicitly stated that they do not claim any level 3 or level 4 results. Everything they published is level 0 through level 2. And this is refreshingly honest. In a field where companies routinely claim breakthroughs and revolution by incremental improvements, DeepMind said we are at a publishable quality. We are not at a major advance yet. Now, before this release, Google actually ran a real-world experiment. They offer a stock 2026 conference author a pre-submission feedback generated by an earlier version of DeepThink. And the tool reviewed papers for mathematical correctness, identified calculation errors, incorrectly correct inequalities applications, logical gaps in the proofs, in real stuff that breaks a paper, which was, I think, a very interesting application of this technology. And to be honest, this is probably more important to me than any benchmarks that we are seeing. We are looking at an AI tool that is already being integrated into paper reviews at the top academic conferences. We're not talking about replacing reviewers, but rather helping authors catch errors before submission. Okay, so what exactly are the takeaways from this new release? I think there are 3. Now, the first one is that inference time compute scaling works and it's getting dramatically more efficient. We are talking about 100x reduction in compute for the same quality in 6 months. So here we are not talking about bigger models equal better. I think this is smarter thinking equals better with an agentic loop, which is fundamentally different scaling paradigm than what we have been living in the past few years. Second is going to be the importance of harness and agent being better than the raw model. If you're building any agentic systems, the orchestration layer is going to be the most important one, because this is where I think we're going to get the most gains other than retraining the models. And the third is that we're seeing early glimpse of AI research collaborators, and not just a coding agent that can generate code for you, but an AI system that can actually do research and solve hard problems. Now, these are very early days, right? As we saw, we're looking at 6.5% success rate on the hardest problems, but still, this is humbling for a system that is supposed to be just a next token generator. And just like coding system, I think these are going to be early signs of a junior capable researcher that can help you with some tasks. So really exciting times, and I'm actually excited for where this goes beyond just the benchmarks and normal demos that we create. Now, this is very exciting stuff. One thing, don't try Gemini 3 DeepThink on normal one-shot prompts, this is probably not going to impress you. But if you have hard technical problems, I'd highly recommend to put it through it, and you're going to be surprised. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.